Hi, this is Jeline from the Honors Tutorial. Welcome to part 3 and the last part of our topic, which is about finding the greatest common factor of 2 to 4 numbers for Mathematics 5. So we are done with listing method. So now let's have the other method, which is the prime factorization. So it is a process of factoring a number in terms of prime numbers. So we have here examples. Find the GCF of 18 and 54. But I want you to know that there are two kinds of prime factorization. The first one is the factor tree method, and the second one is the ladder method. So the method that we are using or that we will be using here is the ladder method. Okay. And this is how you are going to do that. So let's write 18 here. And then write this symbol. It looks like a ladder. And then think of a prime number only. Take note of that, prime number only. So think of a prime number that can divide 18. We can use 2 here. 2 divided by 18 divided by 2, that's 9. And then think of a prime number that can divide 9, and that is 3. 9 divided by 3, that is 3. So think again of a prime number that can divide 3, and that is 3 itself, because 3 is a prime number. 3 divided by 3 is 1. So therefore, the factors that we have here is 2 times 3 times 3. Let me write it here below. So this is equal to 2 times 3 times 3. Next, factors of 54. So for 54, we have here 2. We can use it. 54 divided by 2, that is 27. And then we can use 3 to divide 27. 27 divided by 3, that's 9. And then use 3 to divide 9. 9 divided by 3 is 3. And then use 3 again. So 3 divided by 3 is 1. So therefore, the factors that we have here for 54 is 2 times 3 times 2 times 3 times 3 times 3. And then what are we going to do next? We have to rewrite. So let's use the other part of this board. So now let's write 18 equals 2 times 3 times 3. And then below that, we have here 54 equals 2 times 3 times 3 times 3. And then after that, this is what you're going to do. You have to box numbers which has a partner. For example, 2 and 2. It has a partner because we have 2 for 18 and 2 here below for 54. So let's box it. And then let's look for other partners. We have here 3 and 3. So let's box it because it has a partner. And then we have here 3 and 3 again. Box again because it has a partner. How about this 3? We will not box it. So therefore it is not included because it doesn't have a partner. So now how are we going to solve for the GCF? So GCF is equal to 2 times 3 times 3. Why is it 2 times 3 times 3? Because those are the numbers that we have boxed earlier. Per box, you will write the number once only. So therefore, though you have here 2 and 2, you will write it as 2 only. Though you have here 3 and 3, you will write it once only. So that's why we have here 3. And also, though you have here 3 and 3, you will write it once only again. So that's why you have here 3. So that's why we have here 2 times 3 times 3. And then we have to solve for it. 2 times 3, that's 6. So times 3. 6 times 3, that is equal to 18. So therefore, our GCF here is 18. And that's the final answer. No need to list the factors, just solve it using the ladder method. So this method is called the ladder method. Some of the books that is written is having the ladder method or the continuous division method. But they are the same. Ladder method and continuous division method are the same, but differ in the names. Let us have another example. So we have here 27 and 72. Same process. Let's use the ladder method. So we have here 27. Think of a prime number that can divide 27, and that's 3. 27 divided by 3, that's 9. Think of a prime number that can divide 9, and that's 3 again. 9 divided by 3 is 3. And then for 3, we can use 3. So 1. So for 27, we have here 3 times 3 times 3 for 27. For factors of 72, kindly think of a prime number that can divide 72. We can use 2. 72 divided by 2 is 36. And then think again of a prime number that can divide 36, and that's 2. 36 divided by 2, that's 18. And then think again of a prime number that can divide 18. We can use 2 again. 18 divided by 2 is 9. Think of a prime number that can divide 9, that's 3. 9 divided by 3 is 3. Think of a prime number that can divide 3, and that's 3. So therefore, for 72, the factors that we have here, prime factors, is 2 times 2 times 2 times 3 times 3. Okay, so now let's have the GCF of 27 and 72. So let's write the prime factors of 27 first. And that is 3 times 3 times 3. And for 72, let's write the prime factors. Those are 2 times 2 times 2 times 3 times 3. So I want you to encircle the partners that we have here, if there is any. If none, it's fine. So let's start. Is 2 included? No, it's not, because we don't have 2 here above. Another 2 is not included because we don't have any partner for it. Next. Another 2 is not included because we don't have any partner here above. But for 3, we can have that. This one and this one. So it is one partner. And then for, let me just use another color so that you may know the partners. White and white, and then you can use here blue and blue. So therefore, for our GCF, it is equal to 3 times 3. It is because we have here two partners. It just happened that they are both 3. So 3 times 3 is 9. So therefore, our final answer here is 9. This is the GCF already. And let's have the last part of our topic. So that is 40, 100, and 120. So let's have 40 here. Think of a prime number that can divide 40, that's 5. 40 divided by 5, that's 8. Prime number that can divide 8, that's 2. 8 divided by 2, that's 4. Prime number that can divide 4 is 2. 4 divided by 2 is 2. Prime number that can divide 2 is 2. So therefore, we have here 5 times 2 times 2 times 2. Let's have another for 100. Um, 100 here. Then think of a prime number that can divide 100, that's 5. 100 divided by 5 is 20. A prime number that can divide 20 is 5 also. 20 divided by 5 is 4. Prime number that can divide 4 is 2. 4 divided by 2 is 2. Prime number that can divide 2 is 2. 2 divided by 2 is 1. So therefore, the factors of 100 is 5 times 5 times 2 times 2. Let's have another. So we have here 120. Let's write 120 here and then think of prime numbers that can divide 120. We can use 3 here. 120 divided by 3 is 40. And then think of a prime number that can divide 40, that's 5. 40 divided by 5, that's 8. Prime number that can divide 8 is 2. 8 divided by 2 is 4. Prime number that can divide 4 is 2. 4 divided by 2 is 2. Prime number that can divide 2 is 2. So we have here 3 times 5 times 2 times 2 times 2. Then now let's look for the GCF. Let's write it here below. For the GCF, let's write the factors of 40, 100, and 120. For 40, we have here 5 times 2 times 2 times 2. If you want to write it as 2 times 2 times 2 times 5, there's no problem with that as long as they are the same number that you are using. And for 100, we have here 5 times 5 times 2 times 2. That's for 100. And then for 120, let me write it here above because you might not see it here below. So we have here 120 is equal to 3 times 5 times 2 times 2 times 2. Okay. So now let's use and choose our GCF. Please look for the partners that we have here or that we might have here. We can have this 5, 5, and 5. Though it is not a straight line, but they are partners because we have 5 for 120, 40, and 100. So it's fine. No problem with that. And then we can use this 2 and this another 2. Is there any? So for this, there's none because we don't have partner for 3, 2, and 5 anymore. So therefore, for GCF, we have here 5 times 2 times 2. So 5 times 2, that's 10 times 2. So 10 times 2 is 20. So therefore, the GCF of 40, 100, and 120 is 20. Okay. So if you have inquiries about this topic or about us, kindly message our FB page, The Honors Tutorial. Thank you for finishing part 1 up to part 3 of this topic. God bless.